Good afternoon, everyone. Let's have a fruitful day. Listen attentively all throughout the video.
For our objectives, first, understand the concept of internal energy. Second, solve worded problems pertaining to internal energy. And last, cite application of heat and internal energy in our daily lives. For our today's topic, we're going to discuss about heat, work, and energy. Before we proceed to our next topic, let's have first a short review. So when we say energy, energy cannot be created or destroyed. It may be transformed from one form into another, but in the total amount of energy never be changes. We have the potential and kinetic energy. Energy of position or energy in storage is what we call potential energy. The energy of motion, the form capable of doing work, is what we call kinetic energy. And the unit used for work and energy is what we call joule. Let's feed your vocabulary. First word, temperature, the amount of heat energy available of work in a system. Next, heat, the energy in transit from a body of higher temperature to a body of lower temperature. Next, work is the product of the force of an object and the distance through which the object is moved. Internal energy. A substance is the sum of molecular kinetic energy due to the random of motion of the molecules. The molecular potential energy due to the forces that act between atoms of molecules and between the molecules, and other kind of molecular energy. Last, adiabatic process is a process without gaining or loss of heat. Let us now move on to our discussion. So the concept of conservation of energy states that energy cannot be created or destroyed. The first law of thermodynamics is actually based on the concept. It states that the change in internal energy of a system equals the difference between the heat taken in by the system and the work done by the system. So when we say internal energy of a substance is the sum of molecular kinetic energy. When the heat flows in instances where the work done is negligible, the internal energy of a hot substance decreases, and the internal energy of a cold substance increases. While heat may originate in the internal energy supply of a substance, it is not correct to say that a substance contains heat. The substance has internal energy, not heat. The word heat is used only when referring to energy actually is transit from hot to cold. The law is expressed as delta U is equals to Q minus W, where Q, the amount of heat flowing in the system during a given process. W is the net work done by a system, and the delta U is the change in the system's internal energy. Okay, let's try this. We're going to use GUFSA in solving word problem. So we have here the given unknown formula and the solution. So for this word problem, our answer is 150 joule. Things to remember, if the heat is added to the system, then the internal energy of a system increases. Q is positive. Okay? If heat leaves the system, then the internal energy of a system decreases. So Q is negative. If the work done is done by the system, then the internal energy of a system decreases. So the W is positive. If the work done on the system, then the internal energy of the system increases. The W is negative. Before we end this discussion, let us cite the importance of energy in our daily lives. Energy has been so important in such a way that our lives depends on it. Due to the importance of it in our lives, it gives us a faster life to everyone, meaning faster transport, fast manufacturing process for industries as well as faster communication. So for your quiz, I have here a 5-item questions. For the direction, choose the letter of the correct answer. So for your homework, I have here 3-word problems. You're going to solve the following.
Thank you for watching. I hope you learned a lot today. Keep safe and God bless.